My name is Pilot Officer Shannon Breen. I'm a fourth year aeronautical engineering student in the Royal Australian Air Force studying at UNSW Canberra. So my thesis involved coating ultra-high molecular weight polyethylene fabric in order to improve the surface energy, in order to improve the ballistic characteristics of the fabric. Approach of projects, essentially it was my supervisor's main interest in that area, in that field, especially working with ultra-high molecular weight polyethylene. And I'm sort of carrying on from his work, what he's previously done, but in a unique field where I'm coating plain weave fabric that hasn't really been applied before with spray-coated polymers. So yeah, that was a new field that we explored and looked to improve. In the lab, as a prerequisite test, we did a single yarn pull-out testing, and based on the results we obtained there, we moved on to ballistic testing with the gas gun behind me here. Based on performance, we carried through 3 coated samples and tested them at 5 different velocities. The main discoveries we found was the rubber-coated polymers, the spray coatings that we used were the best performing in both the yarn pull-out testing and the ballistic testing. So one of the main assumptions we made before the yarn pull-out testing was that the results obtained there would correlate directly with the ballistic testing that we did post yarn pull-out testing. And that assumption was correct, and that really helped the project moving forward. So ultra-high molecular weight polyethylene is used in various applications, including body armour, which is the ballistic aspect of it, which we're testing in particular. The plain weave variation of UHMWPE is not particularly used in body armour due to the low surface energy, which is why we're trying to coat the fabric in order to improve that, to make it competitive for the unidirectional variant of the fabric. This fabric is found in both hybrid armours and soft armours, so it can be used in any sort of field where that's required.